All right, so sorry about the video being two videos, not one. The program froze. Okay, so a particle moves on the interval from 1.25 to 3.75, and we want to know what values of t in the interval is the line tangent to the path. We want a tangent line that's vertical. So to do that, that means that we need to have the derivative dy dx, because that's where we get tangent lines from. For it to be vertical, that means that the slope has to be undefined, so we're going to have a number on the top and 0 on the bottom. So that means that I'm taking x prime and setting it equal to 0. So x prime is going to be the derivative of cos is negative sine pi t times the derivative of the inside, which is pi, and I'm setting that equal to 0. So for my first step, I went ahead and divided the pi over and divided the negative over, and that gives me sine of pi t equals 0. And so then I looked at, thinking about the unit circle, where the unit circle has a y coordinate of 0, and that's at 0, and pi, and 2 pi, and 3 pi, and 4 pi. I just wanted to write a few answers since my interval wasn't 0 to 2 pi. I wanted to, I don't know, give enough answers to make sure I had everything. So then I went ahead and I divided by pi, and I got that my t value is 0, 1, 2, 3, 4, and the only ones that were on the interval were 2 and 3. So at this point, if I didn't have any time left on the test, I'd say 2 and 3, call it good. But we do have to remember that if it's 0 divided by 0, it could be a cusp, and what I wanted to do is I wanted to make sure that neither one of these numbers provided a cusp on accident, you know, that t value would also make the y prime 0. So I went ahead and I found y prime. So 3t squared minus 48t plus 45. And I factored this just to make sure that neither one of those was a factor. So GCF of 3. And that factors to t minus 15 and t minus 1. And so that tells me that 2 and 3 are not cusps for this problem, and 2 and 3 really is what the answer should be. All right, so moving on to the free response. So we have a particle moving, and they gave us the acceleration vector. For part A, they want the velocity vector of the particle when the time is 0, and they did specify that at t equals 0, the particle is at rest. So the velocity vector, since the particle is at rest, is going to be 0, 0. Now, I was kind of annoyed with this because all I did when I did it the first time is I wrote 0, 0, and then I looked at the answer key and it said that this was worth 1 point with an answer with a reason. So if you didn't have a reason, you wouldn't get a point for this, but they didn't say that you had to explain your reasoning. Anyway, so that annoyed me. But apparently you needed to explain your reasoning on this one. So the reasoning is if the particle's at rest, it's not moving left or right, it's not moving up or down, and that's why the velocity is 0. So something about both components of the vector need to be 0 for this to be considered at rest. All right, for part B, it says give the velocity vector at the time t equals 3. So now we're getting some specific numbers in here, and what you'll notice is that the questions tend to build on themselves. There's not a point in the free response where your answer for D helps you do A. It's possible that your answer for A might help you do D, but it's not going to go backwards. So these problems, if they give you part A, there's enough information in the problem itself to help you answer part A. If you're doing part C, there's enough information in the problem and part A and B to help you answer C. So some of you guys have used, as you have been doing your practice tests, I've noticed that you've been taking information from later on and trying to use it to solve something in the beginning, and it's making you go off on tangents that are not correct for the problem. So for B, we got to find the velocity vector. So I need to integrate t to the 1/2, and I need to integrate 1 over 1 plus t squared. So t to the 1/2, that's going to be 2/3 t to the 3/2 plus c. Over here, this is going to be tan inverse of t plus d. There's our velocity vector. We know that at time is 0, it's at rest. So I know if I plug in 0, then I get 0. Tan inverse of 0 plus d equals 0. So this one's pretty easy. That's nothing. So c equals 0. So that means our velocity vector is 2/3 t to the 3/2 plus nothing. Over here, I had to think about what y divided by x was 0, and I knew that that would only happen for the point 1, 0 and -1, 0. Tan inverse functions only, you only use points, you only use answers that are on quadrants 1 and 4, and I remember that from teaching pre-calc. So that tells me that if I'm choosing between 1, 0 and -1, 0, then 1, 0 is the answer. And that's at 0 or it's at 2 pi, so 0 is probably what we're getting at here. And so d equals 0 also, so not 3 yet. So there's our velocity function, or velocity vector. And now to figure out what the velocity is at 3, I just went ahead and plugged 3 in. So that gave me 3.464, 1.249. And I went ahead and I actually stored those numbers because I wasn't sure if I was going to use them later or not. So I stored this one as x and I stored that one as y. That problem is worth 4 points. 1 point to integrate this one, to get the antiderivative of this as being this part. 1 point for getting the antiderivative of this one to be this point. To find this part where we're solving for the constants of the integration is worth 1 point. And then 1 point for the final answer. So this one right here is worth 4 points. All right, for part C, they're asking how fast is the particle moving. So they're asking for the speed. The speed is just the magnitude of the velocity. So I said magnitude of the velocity, and it's the speed at the time is 3. So I did the magnitude of 3.464 squared plus 1.249 squared. And I didn't use the rounded answers. I used the stored numbers in my calculator, and I got that this was approximately 3.682. That was worth 2 points. 1 was the expression for speed, and 1 was the answer. Now, when they wrote their expression for speed, they did not do these decimals. They took these functions with 3 plugged in. I'm not sure how nitpicky they are on that, so just food for thought there. And then for part D, it said, what is the total distance traveled by the particle in the time interval? So, you just have to remember the formula for that. So distance traveled 0 to 3, and then I just remember that it's x prime squared plus y prime squared. So that's 2/3 t to the 3/2 squared plus tan inverse of t squared dt, and I plugged that into my calculator and I got 5.006. This one is also worth 2 points. 1 is for having the integral written correctly, and then 1 is for the answer.